Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on discrete distribution, population mean and standard deviation, and expected value. This is part 4 of my video series on this PowerPoint. And we're picking up just where we left off, as always. And this is for a discrete distribution. We're going back over our formulas just to kind of keep you fresh and up to date. And that is, here is our formula for the mean. The mean equals the sum of x times p of x. For the population variance, that's sigma squared equals x times x minus the mean squared times p of x. And for the sigma equals the square root of sigma squared, or the standard deviation equals the square root of the variance. Our next topic on this set of videos is expected values. And since we're talking about probability distributions, we're talking about situations that may occur over and over and over a period of time. The mean will be the expected value we would get if the experiment is done over and over. So we have a mean. If a process is done over and over again, the mean is the long-term average. It is also called the expected value. So the expected value is E and is equal to the sum of x times p of x. Notice that the only difference here is the name. It is the same formula. The expected value is simply the long-term average, and if our process is done over and over again, the mean is the long-term average and therefore the expected value. Let's look at our next example. Example 2. We have a game and we're selecting balls at random. A player pays $6 to play the game. There are 1 red ball, 11 blue balls, and 4 yellow balls. A ball is picked at random. If a red ball is picked, the player gets $36. If a blue ball is picked, the player gets nothing. If a yellow ball is picked, the player gets $8. Find the expected value of the net winnings for the player and interpret. First, let's make a drawing to represent what is happening in the words. A picture is worth 1,000 words. A picture of the words will help you take ownership of the problem. As long as it's the teacher's problems, you will not be able to solve it. You've got to make it your problem. So draw your bucket with the balls inside. We have 1 red ball, 11 blue balls, and 4 yellow balls for a 16 of total. See how much easier that is to see than trying to get those numbers from the words above. First, we will build the probability distribution because the probability of each color is different. A probability distribution is made up of 2 columns, the x or data value columns and the p of x column, or the probability of the data value. What are the data values? Well, that would be the net winning for each pick, not the colors, but a numerical value in the result of picking each color. We need the net winnings for each pick. What are the net winnings for red? Well, a player pays $6, and if they pick a red ball, they get 36. 36 minus the $6 to pay gives us a win of $30. What are the net winnings for blue? If you pick the blue ball, you get nothing. So $0 minus the $6 means that you lose $6. And that would be a negative 6 to indicate losing money. Net winnings for yellow, it pays 6, you get 8. 8 minus 6 would be a gain or a win of $2. This gives us our net winning for each color and thus our X's or our data values. $30 for red, negative 6 for blue, and $2 for yellow. We can add those and put those in our table. Next, we need to find the probability for each pick. What is the probability of being red? We have one red ball out of the 16, or 0.0625. The probability of being blue is 11 out of 16, or 0.6875. The probability of being yellow is 4 out of 16, or 0.25. And again, we can add those numbers to our probability column in our table. Now we need to find the expected value of the winnings for the player. First, remember what our formula is for the expected value. It is the same as our formula for the mean. The sum of x times p of x, and it is another word for the mean. It is the long-term average. Notice because we did not ask for the standard deviation or the variance, it's probably easier just to do this formula and not to use the table. But if you use the table, that is also an acceptable way to do this. So we simply want to add up every x times p of x. There's our x times the p of x times x. And Ms. Borlaug has shown that at the bottom here. 6.25% of the time the player gets a red ball and wins $30. 68.76% of the time the player gets a blue ball and loses $6. 25% of the time the player gets a yellow ball and wins $2. You add that up and do the calculations and you get a negative 1.75. The expected value for the winnings. Now let's look at the interpretation. So if this game is played over and over again, on average, the player will lose $1.75 per game. And for Ms. Borlaug, it's very important that you say those first parts. First of all, the game has to be played over and over again, and then on average, the student, or the player, will lose because it's negative $1.75 per game that's played. And the lose again is because of the negative. I thank you for watching. We're going to stop this video here, and there is still more videos to come, so please watch the next one in this series on expected values and probability distributions. As always, if you are a Walter State student and need more help, please stop by the Math Lab in MBS 222.